whatever operations I had performed in the last video using the Glue Visual ETL will be doing the same using PySpark now. In the last video, I had used the Glue API. Actually, I had used the Visual ETL, which converted the entire flow or the entire DAG to a Glue script. But this time, we'll write the script by ourselves using PySpark. Now, before that, let me tell you how we can use PySpark to connect with database sources and targets. Now, when I say database, it can be relational database like MySQL, Postgres, Oracle, DB2, SQL Server, etc. Or it can be data warehousing systems also like Redshift, Snowflake, ClickHouse, BigQuery, etc. Now, the most important thing to connect to relational databases is a JDBC driver. JDBC is nothing but Java database connectivity. It is used to connect to various different relational databases like MySQL, Postgres, Oracle, DB2, SQL Server, etc. JDBC driver is also needed to communicate with data warehousing systems like Redshift, Snowflake, BigQuery, etc. In most of the cases, JDBC driver would be essential to connect to relational OLTP databases and relational OLAP databases. For NoSQL databases, you can use JDBC connectors or you can use APIs also. That would depend on the database itself. So let's say you are using DynamoDB on AWS or you are using Glue to connect to DynamoDB. That's a different connection property that we have to use. If you are using Cassandra, that would be also different. So for NoSQL databases, it might vary from database to database technology. But in case of relational databases, in almost all of the cases, you'll have to use JDBC driver. Now let's say you're trying to read from a relational database using JDBC. The syntax is like this. We'll just use the Spark session to create a data frame reader, but instead of format CSV or format Park, you'll have to pass the format JDBC. And then the important options like the JDBC URL, the database table name. If you do not provide the database name in the URL, you can mention the database table name using the database name dot table name syntax. Then of course you'll have to provide the user followed by the password and then the driver. Now you see I am taking example of MySQL. In case of MySQL, the name of the driver is com.mysql.cj.jdbc.driver. And this driver is provided by MySQL in a downloadable fashion, which I'll show you how to download a JDBC driver from MySQL. The steps would be similar for Postgres, Oracle, DB2, or any relational database that you can think of. Then if you want, you can provide a query, which is optional. You can provide a partition column and then number of partitions and fetch size. These are needed. The last three parameters, which is partition column, num partitions, and fetch size, these are used to provide more parallelism for Spark, because the way Spark works with databases is that it would create a single connection per task. So let's say you have 10 tasks, then all of them would create a single connection. But the question is which rows the task would read. All of them cannot read the same rows. Then the purpose of parallelism is defeated. So using this partition column, num partitions, and fetch size, we are telling Spark that this is the partition column and the number of partitions should be 10. Now you go ahead and divide the rows as such that all the rows are divided across 10 partitions, and then use the tasks to connect to these individual partitions separately. So this is how we can use the data frame reader using JDBC to read from a database source or a data warehouse source. Similarly, if you have to write, the syntax is more or less similar. We provide the data frame writer like dataframe.write.format. There it should be a JDBC, then the URL, then the name of the database and the table, the user password, and the driver. In case of MySQL, it is similar to the driver that we use while reading. The options of partitions, batch size, truncate, again, these are specific to JDBC writers. And then we have modes like append, override, ignore, and error. Append is used to append the rows to the existing rows in the table. Override would replace all the existing rows and then insert the new rows. In most of the cases, you'll be using append. And then finally, you'll have to use the save API of data frame writer, which can be used to write to the database table. Now, how PySpark in Glue will work with database driver, because when I use the visual ETL, I provide the target, let's say it is MySQL or Redshift, using the Glue connection. We just mention the target in the catalog and the connection is created automatically, which is nothing but a JDBC connection. But how do I do that if I write the code using PySpark? Again, JDBC driver is needed for both relational databases and relational data warehouses. And this is how it works. Let's say a file in S3 and we're reading the files using PySpark in AWS Glue from S3, and then we're writing it to Aurora MySQL. Now, the AWS Glue job that you see here, which is there in the middle, this Glue job will execute a PySpark code. So the PySpark construct would come into play, and we'll have to provide a JDBC driver to this PySpark code and the syntax that I have shown you in the previous slide. And we'll have to combine them together, and using the JDBC driver, we can either write to the database or read from database. Similar would be the case for data warehouses also. In AWS, you have Redshift. So we need to provide a JDBC driver which can be used to either read from or write to the data warehousing system. In this case, it is Redshift. Now, how do I provide that in Glue? So while providing the job properties, while creating the job, I had shown you this option called libraries. Here there are 4 options: Python library path, dependent jars path, referenced files path, and additional Python modules path. For the JDBC drivers that you use, we'll have to provide the driver information in the dependent jars path option because we are using a driver. Now, if you are using, let's say, additional Python modules like PyMySQL or Boto3 or Airflow, something like that, any additional Python libraries or modules that you choose to use in your PySpark code, those would go here in the additional Python modules path. So let us go ahead and do some hands-on. I'll be using a MySQL JDBC driver, and this is the place where you can download the MySQL driver from. I'll show you how to do that right now. And we'll use this driver to read from S3 file and then write it to MySQL. That is the first thing that I'll do. And in the second hands-on, I'll use PySpark code to read from Aurora MySQL database and write it to Redshift using Glue.